All right. Thanks, Mike. All right, so since we're at gas stops, I wanted to do a little bit to pump us up before we have our presentation tonight. How many people have been to gas stops before? Good, this might actually work. That's great. So let's pretend that this is beer. And I'm not going to sing Ein Prosit, but let's do the last portion of that. So when I say ziggy zaggy, you say oi, oi, oi. All right, are we ready? Ziggy zaggy. Oi, oi, oi. Ziggy zaggy. Oi, oi, oi. Roast. Drink. That is so much better with beer, isn't it? All right, so it is my pleasure to introduce our speakers for today, Max Moreland and Brad Eastoshin. And I'll introduce Max first. They're going to kind of tag team the presentation. I think they'll both be up here at the same time. But Max is a professional engineer with SPAC Consulting, where he is currently the most handsome employee on staff. So Max started working at SPAC Consulting in 2011. He's developed his role from data collection to analysis to leading every stage of traffic engineering projects. Max is a graduate of St. John's University and the University of Minnesota and has served on the NCITE board as a director last year. And Brad is with Minnesota Department of Transportation. He's the state traffic safety engineer. His current responsibilities are managing the Highway Safety Improvement Program, supporting the department's Towards Zero Death program, and providing traffic safety technical assistance throughout the department. Brad holds an undergraduate degree and a graduate degree in civil engineering from Iowa State. He is a licensed professional engineer in Minnesota, has a PTOE certification from ITE, and is a certified EMT through the National Registry of Emergency Medical Technicians. So please join me in welcoming our speakers today. Sure. Pop it up there.
All right, thanks, Nick. As you just said, I'm Max. This is Brad. Today we're going to talk about median acceleration lanes. Can you guys hear me back there? Good. And a recent research study project we did regarding these. So to quick just make sure we're all on the same page, a median acceleration lane is exactly what it sounds like. It's a lane in the median that you can accelerate in. So it's typically found on in places on the highway where there's a large median. They kind of cut it out of the middle there. You don't add a lane, so people will have to jog through the main line. On a large median, you can cut it out, and it really helps people turning from the side streets, making left turns, or the main line making U-turns. It gives them a lane to turn into so they don't need to wait for a gap in the oncoming through traffic. So theoretically, it's a safety improvement by removing some conflict points between these turning vehicles and these vehicles. Theoretically. Also, it's theoretically an operational improvement, so people don't have to wait for extra delays waiting for all these gaps coming through here. Traditionally, in Minnesota at least, median acceleration lanes are more commonly used for heavy truck traffic because obviously it takes longer for a truck to accelerate up to speed, so they can use this lane to get up to speed and merge safely without causing any sort of conflict or jam-ups on the main line there. So this study, we had a few key questions we wanted to answer regarding median acceleration lanes. First one is, when are they used? So we looked at a bunch of them currently out there in Minnesota, and we're figuring out when people are using them and if they're being used at all. And for people using them, we also wanted to figure out if there's a difference between cars and heavy vehicles that use these lanes. The traditional car or traditional heavy vehicle. As I mentioned a minute ago, it's thought that they're more used for heavy vehicles due to slower acceleration times, but that's one question we wanted to dig into in this study. We're also curious to see if the amount of traffic that's opposing these turning vehicles has an impact on the number of vehicles that use median acceleration lanes. So if higher ADTs on the highway, or if peak hour times, if people use them differently during different times of the day, in different locations. And lastly, we want to know if historic crash records show an improvement in safety. So we'll look at crash records from places with these acceleration lanes and places without to see if there's really any safety benefit, because theoretically, again, we're all about theories, and there are some safety benefits, we'd hope.
And then from the MnDOT perspective, so those are the detailed questions we wanted to ask. And what we really wanted to look at is we have pretty vague guidance as to when should we use median acceleration lanes. And so one of the things we wanted to do was to say, our road design manual says use it when appropriate. Well, what's that mean? Does it mean high truck traffic, high volume, so forth? So we're trying to tease out, when do these things seem to operate efficiently, and maybe where are they underutilized? And then we also have some pretty prescriptive, if you're going to use them, here should be the length of these median acceleration lanes. And so what we want to say is, okay, is that adequate? Is it inadequate? Are we causing problems? Have we really designed these median acceleration lanes to be the appropriate length? And then, basically at the end of the day, what we want to do is give a lot better guidance and use it when appropriate. So give them some actual scenarios as to, hey, this is going to be beneficial, and maybe your return on investment won't quite be as much under these situations. So from a big picture policy perspective, that's what we were trying to get at.
All right, so for the study, we looked at 12 locations in Minnesota. They're all within about a 2-hour drive from here. And MnDOT picked these locations. I'll quickly show you where they are. Some up near St. Cloud, Highway 65. These ones are on 36th over by Lake Elmo. I'm sure a lot of you know where that is. Some down towards Rochester, and some out past Mankato. All of these locations are 4-lane highways with wide medians that were able to accommodate a median acceleration lane. Speed limits on the roads are 55 to 60 miles an hour. The acceleration lane length at each of these is between 1,000 feet to a quarter mile. Some are closer right around that 1,000 mark. Some are right around a quarter mile in length. Most of these have been in operation for at least a few years. And there's signage out there saying, acceleration lane in 1,000 feet or acceleration lane ends in 500 feet. So it's pretty clear what these things are out there. They're not just extra pavement that people are figuring out what to do. And so all these locations have similar geometric designs, but based on where they are, the volumes and the populations are very different. So the ones, E and F over here near Lake Elmo, the ADTs on Highway 36 are pushing 40,000. So 40,000 vehicles per day. Some of these other more rural ones have ADTs about 5,000. So we thought that'd be a good kind of apples to apples comparison, is do they make a big difference in a busy area versus a more rural area? Yeah, and the ADT ranges on the side streets range from 500 to 6,000. So again, a good range of locations that we have there. So one of the big things we need to figure out is, MnDOT had the idea for this study. They want to look at these acceleration lanes and know if they're any good, if they're worthwhile, any sort of characteristics about it. And we kind of identified about a dozen of these locations, so we want to figure out how can we efficiently look at all of these locations and get any sort of data out of it. So instead of spending 6 months to a year studying one location, how can we just knock all these out in a couple of months? So that led to a lot of internal discussions at our office with MnDOT, and we have a multi-step approach of how we did that. First was to get just mainline ADTs on the highways from MnDOT, so we didn't have to go collect that. They had recent data at all the locations, so that was really useful. And then we set up some tube counters on the side streets at all the locations. There's a photo of me setting up a tube counter, not for this study, but same general idea. So these tube counters gave us our ADTs on the side street. We also got heavy vehicle percentages and directional volumes from there, and we could find peak hour times, so we can narrow down to peak hour usage at the acceleration lanes. And then we set up a camera. Again, this is a sample photo, but we set a camera at the intersection here to be able to see which vehicles are making these turns, these left turns or these U-turns, and if they're turning into the acceleration lane or if they're not going in at all. And then we decided to put a camera at the end of the acceleration lane to basically see if people are still in it all the way to the end, or if they're not, we'll know that they left at some point. We had discussed kind of blanketing the whole thing with cameras, but since it's about a quarter mile in length, our cameras can only see about a few hundred feet clearly. We'd need a half dozen cameras to see the whole thing. And we didn't really want to track vehicles through because that would take a long time. Because these cameras in these tubes were out for a week at each location, so 7 days at 12 locations. That adds up quickly. So we wanted to do the most efficient thing we could do is kind of just find these binary options of are vehicles turning in or not, and if the vehicle's turned in, do they stay in all the way? So we basically have 3 data points at the end that we're grouping everything into. And then all the vehicles we split amongst passenger cars and heavy vehicles to kind of see the difference there. And we also counted farm vehicles, but since it was late fall when we did this, there was only like 5 tractors at all locations over the course of the week. So that's something. Yeah, so we're not perfect, and we're going to admit that right here. We had some issues with our data collection. With tubes and cameras being out for a week at all these locations, there's a lot of opportunities for something to go wrong. We saw some bad weather, had some high winds. Now this is an actual picture from there. No. There was one location where we had to reset because of the weather, and then it ended up snowing during our reset, so then we had to reset it a 3rd time. And that was actually set up at the wrong location, so we reset that one a 4th time. So we had a few things. And then we had one other issue that I've never seen before. I've been setting up cameras for 5 or 6 years, set up hundreds of cameras, and this was a first for me. Our cameras are set up on a long extension pole, and it attaches to a street sign, basically, and the camera just kind of points out and records the traffic. We come up the next week, pick it up. When we came to pick up this one camera that was southwest of Mankato, so about 2 hours away, when we picked it up, the camera was pointing straight at the ground. And obviously that's really depressing when you go all the way out there, you see your camera pointing straight at the ground. So we bring it back to the office, scrolling through the video to see why is it pointed straight at the ground. And I'm scrolling through, and then this pops out at me. This bird attacked our camera, and I jumped out of my seat. And this happened like 2 hours after we set it up. So we had to reset that one too. So MnDOT obviously was very understanding and accommodating with these issues that we ran into, and we were able to kind of work with them, say like we got a few days out of this one, we didn't get any out of this one, so we'll reset here or we're okay here. So some of the locations we got the exact 7 days, some locations we got maybe 5.5 or 6 days, and some locations we would get 2 days and we reset, so we ended up getting 9 days. So in general we got about 7 days at each spot. And just, I know you're all really excited to see what this looks like. So this is just a couple of quick examples of what our cameras look like. This is the median acceleration lane at the intersection. And we basically counted the vehicles if they turned into or not into the lane. So a heavy vehicle didn't turn into it, et cetera, et cetera. We had, with all the locations, about 4,000 hours of video. And I clipped out the most exciting samples I could find. So you see, this was a good one. That guy waited for the gap. He didn't need to, but then he still turned into the acceleration lane. So if this really gets you going, talk to me later. We got plenty of work for you to do. Here's another one. So this guy, he went in. It's exciting. The next guy doesn't go in. The next guy goes in. So, yep. 4,000 hours. Here's a quick sample of the end of a median acceleration lane. So you can see there's 3 lanes here. The center one is the acceleration lane, and we would just basically count every vehicle that was in that lane, and we would timestamp those counts to the nearest 15-minute intervals and have that for a week. Again, these are our most exciting clips. My goal or my hope was that we could watch these at like 20 times speed and crank through them, but you can't, because at 20 times speed it's too hard to tell which lane people are in. So it was a painful 3 or 4 times speed to watch things. I know you guys are loving this. This is the most exciting one. This truck turns into the lane. You see it? Then he immediately gets out of the lane. So there he gets out. So a lot going on here. I was going to show you the bird video, but I thought it'd be too scary. In case anyone has a heart condition or anything, I didn't want to. All right, so after all that, we actually got some results. We didn't just do it for fun. So here's our general results page. This is a weighted average of all the locations. In blue is the vehicles that did use the median acceleration lane, and in orange is vehicles that stayed in it the entire length. Passenger cars on the left, heavy vehicles on the right. So you can see that with passenger cars, about 82% throughout the course of the day will turn into that acceleration lane. And in the peak hour, about 87% of vehicles will. Heavy vehicles, large trucks, about 74% of them will use it throughout the day, and that jumps to 85% in the peak hour. So we were a little surprised that a lower percentage of heavy trucks use it than cars. That was kind of not what we expected. But unsurprisingly, during the peak hour, more vehicles use it because there's likely more traffic and less gaps for them to get into. As far as vehicles staying it the whole way, about 20% of cars did, and about 30% of heavy vehicles did, which makes sense that there's more heavy vehicles staying in these lanes because they take longer to speed up. And these beautiful charts are just, we won't get really into these, but these are just the location by location charts we have. So all the different locations and then the daily and peak hour results. It kind of just shows the variability we saw with the locations. Some of them, like this one, and this one, had really low heavy vehicle volumes, hence why they're spiking like that. These ones had almost nobody heavy vehicles. Those are on 36, where the U-turns only. So there's mostly passenger cars, but yeah, you can see some general trends, but there are some peaks and valleys here and there.
Yep. So then we also took a look at the locations and looked at the crash history. We compared them to some control sections in close proximity, or at least had similar characteristics. And so when we looked at fatal and serious injury crashes, we did see that there was a reduction in the number of fatal and serious injury crashes, which is good from a safety program. The bad thing is those crashes happen about once every 25 years, so the magnitude of the reduction isn't substantial. But you know, in terms of our Towards Zero Deaths program, this is something that could potentially reduce some fatal and serious injury crashes if there was a history that was there. However, what happened when we looked at our rear end crashes is those actually went up. And so, and this was a significant result in terms of statistics. And so those crashes, they increased. Likewise, we said, okay, let's take a look at those sideswipe opposing, that merging action. Nothing really changed in terms of those types of crashes from our control intersections to our treatment intersections. And then likewise, we also looked at our right angle crashes at the intersections, and it was really indifferent on the impact that was there. And so, you know, overall, hey, trends are looking good for fatal and serious injury crashes. Our rear end crashes, they spiked up more than the decrease in the fatal and serious injury crashes. So overall, we've seen a slight increase in our overall crashes at these locations.
All right, so putting all that together, some quick analysis points here. I just saw most vehicles do tend to use these acceleration lanes, so that's good. They're not just being put out there for nothing. However, more cars use them than heavy vehicles, which wasn't necessarily intuitive. Most don't use the full length, about a quarter to a third, and more heavy vehicles use the full length than cars. Again, an intuitive result. Also, usage of the median acceleration lanes is higher in the peak hours than over the course of the day, which makes more sense. If there's more traffic on the main line, it's less gaps, and it's easier to turn into that median lane. One other thing we found is there's not a strong, even though usage is higher during the peak hour than over the course of the day, there wasn't necessarily a strong correlation between the ADT on the highway and the usage of these acceleration lanes. We thought that as the highways get busier, it would be a direct increase in the use of these acceleration lanes. But we plotted all these locations, their ADTs, and then the usage, and it was just like a shotgun scatter plot. There was no correlation really between any of it. So that was surprising, we thought. And as Brad mentioned, there was about 50% decrease in fatal and severe injury crashes and an 18% increase in the overall total crash rate. This was compared to 32, I think, other sites that are very similar to these locations that don't have acceleration lanes, and the crash data from these ones was compared against those. Overall, the total crash rate was still in like, I don't remember the number. It's pretty low. Pretty low. Pretty low.
So back to, geez, what are we going to do with the results of this information? So one of the questions I wanted to answer is, well, is our road design manual guidance appropriate? Well, I don't find anything in here that tells me. I thought for sure we'd see a correlation. There'd be an inflection point somewhere in a mainline ADT that we could say, hey, these should really be considered above 25,000, above 15,000. And as Max said, we didn't see utilization increase as a factor in mainline volume. So strike one, we missed that one. We said, overall our median acceleration lanes needed. They get used a lot. A lot of people use them, whether that's making it easier for them to execute their turn and they're using it for that short distance. But really, when we looked at the overall operational performance, most of these locations are operating at level service A, B, C. The DeMontreville Trail location, probably the peak hour is maybe a D approaching an E type of condition. And so, we didn't see a lot of forced merging or people that had to use that merge lane in order just to find a gap in traffic. And so, swing and miss number 2. And then, are they needed or are they right sized? In our design manual, it's about 1,600 feet. You add in your taper in there, you're looking at about 2,200 feet of pavement. Most of them didn't use it to the entirety. So could that be shortened up? Maybe. I think that, a couple of things we need to look at is we had R-cut locations where we had a U-turn movement, and then we had a left turn location from the minor approach, and we might need to see if those kind of characteristics differentiate themselves in terms of future research here. So, at about 10 to 20 bucks a square foot to construct a section of road, these things aren't cheap. These are a higher cost solution, and it's providing a marginal safety benefit and not really operational thing. So right now the jury's still out, and we got that general guidance that we're going to try to refine a little bit more as we dig into some more details.
Yeah, so just kind of wrap it up here. Most people use them, but we don't necessarily know if they have to use them. There was a study done about a decade ago that looked at kind of something similar to this, and there's some similar usage findings between that study and this study. So with that being a decade ago and the usage being about the same, we don't see that there's a marked increase over time. So there might be a learning curve with these sort of median acceleration lanes, but it's not a long learning curve. We were encouraged by the overall use. Of these median acceleration lanes in general, and the decrease in fatal and severe injury crashes compared to the intersections without them. The increase in overall total crashes could be related to other factors, but that's also still being looked at. MnDOT has some of their top statisticians working on this stuff, and so they're trying to really figure out if the numbers we found here with the crash data, if they're statistically significant or not. So we will find that out. But I'm going to make a strong claim here and say that given the relatively high use of these median acceleration lanes and the decrease in fatal severe crashes, a median acceleration lane could have potential as a safety device. And you always want to end a presentation with leaving the people wanting more. So there's more work needed on this. So that's all we have for now. So if you guys have any questions, fire away.
Can you describe how the rear end crashes were happening in this situation? I can't picture that.
So we didn't do a detailed poll. We pulled a few of the crashes, and a lot of it had to do with people merging or entering into that left lane and the vehicle not being able to slow down. So whether it was the merge movement or they just went into the lane and the vehicle maybe couldn't move right because there was a vehicle in that space and they ended up rear-ending the vehicle.
So similar conflict type of side split.
Right. Yeah, just the position of the way they did. Yep.
Back there.
So I talked to Jim McCarthy at HWA a couple of months ago on some similar work that we were looking at. This is more of a suggestion for you guys for later. So, you know, we're looking at some rear-end crash problems here. We expect 10 years from now, 80% of the vehicle fleet will have some sort of rear-end crash detection system. And so you may see a very different result if you try and run these numbers 5 or 10 years later.
Right.
That's true.
Yeah, I've done a lot of work on arc cuts, and I was curious about this because of the way things are settling out in arc cuts now is you really want to have those U-turns only about 660 feet downstream. So if you do provide a median axle lane, you're going to be running into the left turn lane for the central intersection when you do that. And I've seen some other studies that said these things need to really be a half mile long if you're on a 65-mile-an-hour roadway with a lot of trucks in it. So yeah, there's a lot more work is needed. Where I grew up in Maryland, they've been pioneering in arc cuts over the years, and the actual district I worked for briefly down there has a corridor which has ADTs over 40,000. And they have some locations where they have not only have the median's a little narrower than the ones we would use here. They not only have the median acceleration lane, you also have loons. So the trucks usually go to the loons, go to the outside and wait for the gap to get across both lanes.
Yeah, that's one of the things too. With some of these locations, it's tough, depending on the vehicle movement, for them to get to that inside acceleration lane, and sometimes the outside acceleration lane is more appropriate. Yes, sir.
Is there any signage guiding vehicles in these lanes about the distance? Because it looks like it's white striping, and it's hard to tell whether it's lane if you're on the other side.
Yeah, they will have signs to say median acceleration lane or inside acceleration lane. So there's something that kind of declares that use. And some of it's to educate the mainline folks, but also it's for people that are making the turn to know that that space is really there for them.
Were you able to collect enough crash data to be able to separate it out, look at crashes that only include cars versus crashes that would include trucks making the turn?
Yeah, most of the crashes involved cars. There weren't a lot of truck crashes in our analysis. It was almost exclusively cars.
Yeah, following up with that, I mean, did you look at the comparison between the truck crashes at these median acceleration versus truck crashes at the non-ones?
Yep, and there was no difference. Again, a lot of it was just sample size constraints. In general, our trucks aren't getting involved in the crashes here. It's mainly passenger cars.
Yeah, all up for that, how about the crash rates? So you had an increase in like number of like rear end, how about the overall crash rates?
Overall crash rate went up slightly with the median acceleration. Now we also included that merge area as part of the intersection, and we may have grabbed some mainline crashes that were inconsequential to that movement, but those might have slipped in.
What are you doing to continue your study?
Well, we've got, as you said, our best statisticians trying to dig into some details. We're gonna try to find some more comparison sites and maybe separate out our R-cuts locations from just our full access intersections with the inside acceleration lane, and see if we can maybe get some different comparison groups to maybe tease out some more of the details as to what's working and what's not. So that's the first thing that's on there. I got 4,000 hours of video. I can hire somebody to take a look at it. But no, in all honesty, Max and TDI, they did a great job in terms of collecting the data, delivering things in a timely manner, and so I was really happy with the effort that they put forward on this project, and they did a really good job. So. They had problems. They said, "Yep, Brad, we'll get this taken care of." And so, as a client, I was happy with our interactions and the end product that we got out of it.
All right,